Hello everybody, welcome back to the channel. This is Michael, KE4EST, and we're back here with this Heathkit model IM-102. And of course this is a digital multimeter, come out in the 70s with Nixie tubes in it, as you've seen in part 1. And I'm going to kind of show you what I've done here. Then we'll go over the alignment of it a little bit, and we'll go through doing some testing with it and see how accurate it is. Okay, so what I've done, of course, is changed out this capacitor here, and this capacitor here. Another thing I noticed too, I was trying to find some pictures but didn't find anything really that I wanted, and I've got a part of a manual that I downloaded. It don't have everything in it. It don't have the assembly steps in it. They just skip to it's got the alignment section and some very poorly copied schematics and a couple other things, but it don't have the whole assembly process. So I'm not sure if these, like this heatsink that's on here, came with it. I found one video that was in Spanish that somebody had done, and you know, I still was able to skip through it, and they showed the inside. I couldn't understand the Spanish enough to know what the guy was saying about everything, but it didn't have any heat sinks. Now this one came with this one here. Now whether somebody added this, I don't know, because this does get pretty warm, and this 9-volt regulator here gets pretty warm. It gets warm enough to where I've got plenty of these here, so I just added one to it. So I put another heat sink on that just for good measure. Of course, I cleaned everything, all the contacts, the chips, pulled them, reseated them, and as you see in part 1, replaced this chip here. So all that's been done. I cleaned the face up, you'll see in a minute. Cleaned all the knobs, you know, ran them through their paces. Cleaned them up good. So all that's been done. I checked these resistors, went through all the resistors and checked them, and they checked pretty close. So, you know, I didn't check every single one of them, but I checked enough of them to know that, you know, because some of them, you know, this type of circuit, you're going to have to pull them out, or at least take one end loose. It ain't like a vacuum tube circuit where you can a lot of times get away with just checking resistors in the circuit. And they checked out pretty close, so I'm going to leave them for now. We'll see how it goes. And that's about it. You know, like I said, cleaning it up and all that stuff. I'll go ahead and show you before we go into the alignment here. This down here, this is the zero adjust. This is your ohms adjust. This is your negative adjust and positive adjustment. When you're doing your voltage adjustment and stuff, use those. If I mention negative and positive adjustment, that's those two here. This here is your ohms adjustment. And it says 20K adjust, but the way this is set, it pretty much, you know, gets the whole bottom range. There's a 20 meg adjustment over here for touching up the top end of it. This here is the 40 kilohertz oscillator, 40 kilocycles, however you want to call it, right here. And it, I went ahead and set that. It's really touchy, so I've got that already set, but the manual tells you how to do it. What you do is you'll have the front end of it set on DC volts, and in the jacks you'll have the red, of course, in the red volts, and the black in the common. And you take and clip one to here. It says, it'll tell you in the book, it'll say put one on one of the transformer, number 1. I don't know, maybe if you can see this here. Let's see. Let's make it where you can see this. Yeah, there you go. So it'll say 1, 3, 2, 4. And you clip one here. Use something to clip, an alligator test clip or something with it unplugged, because this is your transformer. And clip the other one to here. Turn it back on and adjust this oscillator. And also, this oscillator has an effect, you know, on the voltage readout. So when you're doing the voltage adjustment, you may want to come back and just kind of touch this up. Just take your fingers, kind of, because it's a wheel that wait a minute, forgot, you can't see what I'm doing here. This here, take your finger and just kind of barely move it back and forth, because what you'll find out is you'll go to this positive adjustment here, and say you've got 10 volts hooked up to it, a voltage reference of 10 volts or something hooked up, and you go to adjust it, and you'll get to like 9.96, 97, maybe 9.98, and you just can't get it. It's at the stop, and there's no actual stop in these where it just stops. It'll keep spinning. But if you feel real close or listen close, you hear tick, tick, tick. So you know you're at the end of it, at the end of its travel. So you'll have to kind of adjust this, once you go through the procedure, because you adjust this first. But you go through and adjust this, and it won't. So you kind of bump this up just a little bit, pull it towards you just a little bit, just come this way just a hair, and it'll go up, say 10.03 or 0.05 or something. Then you can take this and back it down and get it, where you want it. That's real touchy, so I want to just go ahead and get that done. I will show you the zero adjustment, which is real simple. But let me get all set up for the alignment, and I'll be right back. Okay, I'm back here to do the alignment. You can see it's not dead on zero. So what you do is you have these in here, make sure this is on DC volts. Put this on your scale here, and just what I've done is took alligator clip, test lead, and just clipped them together. Clip your leads together, and you'll take and adjust it, and I'm on that zero adjustment, and it's touchy. Coming down now. If you keep going, eventually this positive here will jump down to negative. But you kind of got to play it by ear. It says look for rocking indicators, but where it's plus minus, plus minus, plus minus, and you're like, this ain't going to exactly do that. So you got to find that sweet spot there where you're zeroed out. And another thing too is you can see, I'll put the light here, you can see I cleaned up everything, a little dust and smudges from my fingers and stuff here, but cleaned all this up. This chrome cleaned up good. And if you look here, I replaced that one that was out, the positive, and I went ahead and changed out the negative too, because the positive's so bright now, it makes the negative look dim. So, and what I use is those dot indicators that was used, if you got bigger digits and you got decimals, big decimals in between them, like I used in the other video. That's what I use, is dot indicators, and they're INS-1 is the part number on those. If you want to look up some and buy them, you can get lots of them, new old stock, on like eBay or something like that. But I replaced that and replaced this one. You don't see it lit up right now, but it was definitely a lot dimmer. If you remember me saying how dim it was, but it's definitely bright now. The over indicator works. It's a little dim to me, but I may try something later to change that out. I don't know. But I got all that done. But that's the first part of the alignment. Just clip them together and get that done. And then it goes into using a voltage standard if you have one, or use another meter that's better quality, or there's different ways. But what we're going to do here, I want to use one of these little boards you can get. I've got 2 or 3 different ones of these. This one here is just set for 10 volts. And I'm going to hook that up with test leads. For the voltage adjustment. Make sure we're in volts, and over here on this side on volts. I'm going to go on this side and we're putting voltage to it. We'll blow that fuse again. If you remember from the first video. That there. Okay. Yeah, we got over flickering over here. See how weak that over is? Let's go down one here. Okay. It's not too bad. What you'll do, let's see if I can get on it back here. Let's go back to this positive adjustment here. And just adjust that. Right there's 10 volts. That's what I'm using now. If you don't have one of these, but you have a more modern meter, you know, this mentions in the manual, says use something that's 5 times more accurate than this is. But this was in the 70s. Now, you know, 40, 50 years later, we've got stuff that's, even some of the cheaper handheld digital multimeters you can get, you know, offshore, are surprisingly pretty accurate. So if you have a decent meter, you know, or even a decent name brand meter, like Fluke or something like that, or Agilent or Keysight or something, whatever you have, or Keithley, and it's you use anyway, but you want to restore this, hook it up to a power supply, hook them both up, and it don't have to be exactly 10 volts. It can be whatever, but match them. If you're pretty sure your other meter is pretty accurate, then adjust it so if you hook it to a variable power supply and you got it reading 12.89 volts, you know, just making up a number, you can adjust this to make it say 12.89 volts so it matches the other meter. Okay, and that'll be, you know, perfectly fine. It's a good way to do it. And then, you know, check different ranges. Now if you notice here, if I go, let's see what this does here. So if I go 200 volt scale, we're getting 9.9 there. Okay, that, you know, it's trying to go 9.8. You know, it's going to be a little bit different. If you do a lot of voltage measurements in 200 volt scale, you know, adjust everything to 200 volt scale. You know, that's why the expensive meters, some of these meters, you're like, why are they so expensive? I go buy, you know, 4.5 digit meter or something, bench meters, $400, or, you know, for a lower end model like Siglin or something. Or if I go with Keysight, they're wanting almost $1,000. You're like, why is it so expensive? Because they've got a separate circuit. And this one's going off all in the same oscillator, same circuit for, you know, we're just kind of adjusting it all the way through from 200 millivolts up to 1,000 volts. They've got a separate one for each one that you can calibrate and adjust so that you, when you switch ranges, it's going to be dead on. You know, so that's one reason they cost more. But you can do that so you can, you know, adjust it. You know, use a modern meter just to go by and do that. The manual mentions that the 20 volt scale is most critical, and mainly that's because the way the oscillator is set up, and because that's what you're going to use most of the time as a hobbyist. You're going to be using 3.3 volts, measuring something that's, you know, higher than 2 volts. 5 volt signals, you know, 12 volt signals, or 13.8 volt signals, you know, if you're an amateur radio operator, or not signals but voltages. So that's going to be your main area, so that's the one you want to try to get the most accurate. And it also mentions too, you know, it says in the manual let this warm about 15 minutes before you do that. Once you get everything, go through everything, I'd advise putting the covers back on it. Let it run for a couple hours. Because it's not vacuum tube, it ain't going to get really hot inside, but there is heat in there, and it's going to, you know, make a difference. And, you know, or any maybe RF interference from LED lights or something getting, you know, around the oscillator or something. So when you got the metal shell on this thing closed up and it's running for a few hours, go through and adjust it. A few hours later, adjust it again. The next day, adjust it again, let it run. You know, get this thing as accurate as you can get it for what, you know, you're using it for, right? So that's what you'd want to do. Now, and it's the same thing on the back. And I think I already went through that, but let's see. So I was checking out that ohms scale, you know, for resistance, and that we changed out that fuse. But let's shut this voltage off here. Let's disconnect this. Well, now let's leave my alligator clips here so I can clip on to this. I'm gonna clip on that resistor. Go over here. The 2K range, and this is a 1K resistor. That's not bad. Because I've already went through that one time. We can go back here. Get on it there. See, I can adjust that. It's really touchy. This is a 0.01% tolerance resistor. So right there's, you know, it's a 1K resistor, and we got it reading right at it. Let's see if we go up what it does. See how it's going to be a little bit off each range. Especially, that's not too bad. We get up here in the mega ohms range. Well, that's reading right. This should read 0, 20 mega ohms. There's another adjustment in there for 20 mega ohms that you know, definitely have to pull the shell off of for. But it's not too bad. So if we just randomly, this is 7.15K. So go right there. Let's see what this is showing. 7.2, 7.19. Not bad. Not bad. So yeah, this ain't too bad. Oh, here's that temple capacitor I pulled out of there. You don't see that. Those other two I pulled out. I always throw them away anyway, but I always kind of like to check them just to see. Sometimes on these things, just curiosity, and they tested out okay, except for this one. And you know, just can't make this stuff up. You think, well, this guy just hates Temple Company or something. But no, this one was. It showed the capacitance was really close, but it was showing leakage, and I wasn't even getting close. It's 15 volts rated. It didn't get close to 15 volts, and it was showing leakage. So there it is. Went through it, cleaned everything up, changed those out. That there to me is still a little crooked there, but and it's not in the little holder. But the holder, if you put it in the holder's kind of back further. It makes it look worse. So whoever had it before took it out of the holder and just had it kind of stuck there, and I see kind of why they done that. But anyway, so I hope this video's helped somebody out and you've enjoyed it. If you have any questions or comments, I'll be more than glad to answer them or help somebody out or whatever. Always feel free to put them in the comments down below. And until the next video, this is Michael, KE4EST 73.